Good morning, Tulsa Weld School. I'm Bryan Hatch. I'm a pipe fitting program specialist for Tulsa Weld School, Jacksonville. Glad to have you with me today. So you finally graduated professional welding. You're feeling pretty good about it, and you're in your last week of pipe fitting. You've learned all the takeoffs, all the formulas, how to properly square up your flanges. You've learned how to do everything just the way it should be done in the booth. Now you show up to your first day on the job, and the foreman says, well, welcome to blah, blah, blah. Now I have a job for you. I need you to go and weld up that spool piece that's on the bench there. It goes on the Tug 528C bowl. And he hands you your job. So you read the job, and it reads as follows: Tug 528C bowl. Job control number 397-281. They match. We have the right package. And it states repair or replace approximately 3 feet of 2-inch carbon steel pipe spool in accordance with blueprint 194-321-689 Rev B for reference only. So I'm going to use that blueprint as a reference only. I pull up the blueprint, and it shows me the diameter is 29.5 inches. It shows me everything is square and true. And I'm looking at this pile of junk on my bench, and I'm thinking, how could this possibly be? So the first thing I want to do before starting my spool piece is inspect what I have. It also tells me not only to use the blueprints for reference only, but to build it as per shipboard conditions. So obviously, whoever went and looked at the job just pulled the spool piece off, brought it, set it on my bench, and I need to replicate this to where it fits up as per shipboard conditions, meaning wherever those flanges sit is where the spool piece is going to go. We could see very clearly that there was a corrosion condition that caused the pipe assembly to leak. It's degraded. The welds look like a bucktooth alligator chewed on them. I mean, it's just all the way around bad. First thing I'm going to do is check my flanges for square. I take my framing square and I place it right up to my flange. As anticipated, I have a huge gap up here. What that tells me is this flange is not square. And I look at the other side, same scenario. My flanges aren't square. Now I want to see, because the blueprint shows these bolt holes perfectly aligned straight across from each other. And as you can see on my backdrop, I have a parallel line which is completely level, which should indicate where these flanges should sit if I were to build it as per print. Now, if I come here and I align this up square, these bolt holes here on this flange should also be the same. They are not. They're way out here in left field. This is the real world. Welcome. This isn't going to work. But if you build the spool piece as per print and get it perfect, it's not going to fit where it came out of. Now, some people will teach you to weld, some people will teach you to fit. I'm going to teach you how to make money. Some people will tell you money won't make you happy. That's what broke people tell broke people to feel better. Stay with me. Now, I got my spool piece. To replicate exactly what I have, which is wrong, I need to build it wrong to make it right to fit in the spool that it came out of, in the pipe assembly it came out of, the flanges on the Tug 528C bowl. So I'll take an expired set of flanges, meaning a set of flanges that have been used extensively, and I'm going to take the gasket mating surfaces, that's the ridge side, not the neck side, and I'm going to bolt it up to the current flanges that are on here. I'm going to align them. What we have to do to align our flanges exactly as they came off the vessel is to bolt up sacrificial flanges that are going to be expendable to mimic what we had on the vessel. This is called targeting. Notice I have no formulas. I have no mathematical values. I haven't even broke out a tape measure yet. Because whether this is right or wrong, I have to replicate it for it to work. If you're fortunate enough to have a pipe flange alignment tool, you can slide it in and just screw it and two-hole it. two-hole, meaning on one side, I'll have one, and straight across catty corner, I'll have another. That tells me all the holes in this flange are going to coincide and align. Since I'm brand new to the industry and I don't yet have pipe flange alignment tools because I'm paying, my bills and living and just starting out work, what I'll use is targeting bolts. Targeting bolts are usually painted red, orange, or yellow. What this means is the specification is going to call out what type of fastener I need to use in this system. Since I'm putting in a bolt just to align it, and it's not going into the permanent system, I have it painted so the inspector, if he were to walk upon it, he'd say, okay, that's a targeting bolt, it's coming out. Now, I will align this one. I will hand tighten it. Doesn't have to be super tight. I'll go straight across and I will align this one. So I should be about good to go, right? No, says I. Why? Because my flange is not straight. There's enough slop in there where I could still get it off kilt. So what I'll do is I'll roll my pipe to make sure that my flanges are perfectly centered on each other. I want this to be exactly like it came off the vessel. Once I feel that I have that satisfactorily, I will grab my wrench, slightly snug it. Doesn't have to be super tight, it just has to stay in place. Keep in mind, when the spool piece came off the vessel, there were gaskets in there. They're about 1/8 inch thick each. They're Garlock. They got disposed of. Gaskets will go in at 1/8 inch thick each. I'm not going to account for them because all I'm trying to do is replicate what I have. I'm not worried about what's on the vessel right now. I'm worried about reproducing this piece, nothing more. So I will not compensate for those gaskets. Now moving right along, we've got our flange, our sacrificial flange bolted on one side, our targeting flange. I'm going to do the same to the other, gasket face to gasket face. I'm going to align those holes. Once again, I do not have pipe fitting alignment tools, so what I'm going to utilize is these targeting bolts, which are painted to reflect as such. And I'm going to try, if I can, to get the bolts to mirror each other so that when I go to weld it up in place, the fasteners are not getting in the way. So it's preferable if you can. Of course, these are so misaligned that no matter where I put them, they're not going to be perfect across from each other because the pipe fitter that assembled this didn't know what he was doing. Now you, the professional Tulsa Welding School graduate pipe fitter, is going to have to repair his incompetencies, his or her. Now, I'll snug that up. This is nice. I can roll it. I don't have an unbalanced tire. That means that these two are just fine. Now what I'm going to do to mimic what I have on the vessel, I'm going to take these flat bars and I'm going to weld them to the base of my targeting flanges. Then I will remove the spool piece, put in new flanges, a new piece of pipe, and bolt it into place, tack it, and from there I can weld it. Now the beauty of this setup that we have here is if I were to weld this in place on the ship or on the tug, I have to take all my welding machines, I have to take 140 feet of leads, I have to take an air compressor, I have to get a hot work permit, fire watch. The cost of doing business has gone up because I have to employ multiple people to carry out this evolution. But because it's just sitting on my workbench, I could take one pipe fitter welder combo, like Bryan, and have him or her fabricate this entire assembly right here on the bench, no hot work required. When it gets done and it's completely welded off, we can carry it right back to the vessel, bolt it up in place, and you know what? It's going to fit perfectly. You know how I know? Because this one came out of it. All right, now, here we go. First thing I'm going to do is I'm going to weld off these little flat bars as braces, and then I'm going to tack it to my table. This process, mind you, is called targeting. Put on my gloves for safety. Okay, I'm going to stick one down here. Eyes. There's one. Now I'm going to take my other one. I'm going to lay this leg down onto the table. That way when this leg is on the table, I know that they're both square. It'll just help me in setting this up. Eyes. Once again, I didn't clean any of that up because I don't care. This is not part of the assembly. This is only for targeting purposes. Now what I'll do is I'll take my entire setup and I will tack it to the table. Eyes. I'm only doing one side. That will make it easier for me to break it off later when I get done and I want the assembly removed. I don't have to grind my tacks. I can just push it over. Eyes. Now, when I pull this spool piece out, these are just sitting on a flat bar. So they're going to be kind of flimsy. They're going to kind of wobble a little bit. We don't want that because if they move at all, then my flanges will move out when I assemble my new piece. When I go to put it into that spool where it belongs, into the flanges where the spool belongs, it's not going to fit up. Keep in mind, I'm trying to replicate exactly what I have. So what I'll do is I'll take this and I'll tack that to build a brace. Eyes. Now I'll tack it to the table. Eyes. Now it's going to be good and sturdy. It's not going to go anywhere when I take this off. I'm going to do the same thing over here. Let's see here. Bearing in mind I'm not cleaning or prepping any of this. I'm not concerned about weld quality. All I'm concerned about is these flanges don't move because it's not part of the assembly. Eyes. All right, there we go. Now what we've effectively done is we have mimicked the flanges in the position, exact position, on the vessel that they came off of. So now what I can do is take my crescent hammer, remove my targeting bolts, pull them out. My spool piece can come out. I could literally throw away this spool piece now. I don't even need it. because I have a perfect representation of what I'm going to need. I'll just leave that sitting there so it doesn't fall down to the ground, because sometimes your spool pieces will be large. You don't want it to fall down to the ground when you pull them out. Remove my targeting bolts. This is officially garbage. So I'm going to set this aside. I don't need it anymore. Now, with my flanges, which mind you are not square. You can see they're not square. They should have been when it was fabricated. They were not. So I'm trying to replicate the exact scenario in which I left on the vessel. So what I'll do, I'll take my new flanges for my new assembly. Grab me a little flapper, because cleanliness is next to godliness. Here, the weld quality will matter. This is part of the assembly. And I'll just hit that real quick. There it is. It's all the better I need. Now what I can do is take my pipe, because I measured from flange to flange. I took my pipe fitter stick, which is a valuable tool that costs about, $8 to $15, and you'll have it for 20 years. And this will be the most valuable tool you'll ever have in your box. Guarantee. And don't ever ask to borrow this tool from a pipe fitter. It's offensive. So, I'm going to slide this in, and from flange face to flange face, I have 32 inches. Exactly. But my flanges, being 1 inch in diameter, and I need a 1/2 inch pullback, so I'm going to remove at least 1 inch off this pipe. So what I'm looking at is anywhere between 29.5 to 31 inches should do me. You've got a lot of flexibility here, because this is what is called a P15 joint. What is a P15 joint, you ask? I'm glad you asked. A P15 joint is a slip-on flange. This flange happens to be 1 inch in diameter. It's this 2 inch pipe. And I can slide it on here like this. Now, if I weld this off right there, I will never be able to bolt that up and mate it and get a seal with a gasket, because it's too close. So I got to pull back at least 1/2 inch. So we've measured 32 inches exactly from outside the flange to outside of the flange. These are my existing flanges on the vessel. I have 1 inch inside and 1 inch inside here. But I only want to come back 1/2 inch from the inside. So these are not straight. We already know that they're kind of cocked. I need about 1/2 inch on the inside to get a weld on the inside, ish. So anywhere between, 29.5 to 30 inches should fulfill what I'm looking to get out of this. So I went ahead, I measured this at 29.5. I like to be a little shy, because if I have 3/4 inch on the inside, that's okay. If I have a 3/16 inch, it's not okay. So if you have to err on the side of a little more, a little generous. That gives you some wiggle room. If your flanges are perfectly square, finding an exact numeric will be beneficial. If your flanges are cocked, you want to go a little shy. Not too shy, because you're going to need, ample penetration into the fitting. This is called a P15 fitting. So I slide that in, then I back it out about 1/2 inch. The beauty of the P15 is you can slide your flanges like this, and you are good to go, because you can slide them out. But I'm going to start with my mortise gauge. This mortise gauge, what it'll do, I can loosen it, and I know that I need a 1/2 inch pullback on this. So if I come here and I go 1/2 inch, and this is 1 inch, and I bottom out my pipe, My pipe is bottomed out into the flange all the way. I'm at 1 inch. If I come back a 1/2 inch, and my mark is at a 1/2 inch, I know I have my 1/2 inch in my flange. So what I'll do to start out, I'm going to make 2 measurements. I'll explain that to you why here in a moment. I'm going to come back, take my handy dandy pipe fitter's rule, which also has a depth gauge. This here can measure depth by going to a face, and you can just slide it through. So I'm going to slide it through, and I got a 1/2 inch right there. Now what I can do is I can set up my mortise gauge to where the carbide is right there at a 1/2 inch, and I can tighten that up, snug it up. Now all I got to do after you tighten it, inspect, measure twice, cut once. So we're at a 1/2 inch. Beautiful. Now what I could do is I could take my pipe and I could take my mortise gauge onto my pipe and get that 1/2 inch. Now when that 1/2 inch, and I scratch it on here. Now when that 1/2 inch is at the face, I know I got a 1/2 inch. So what I'm going to do after I get that 1/2 inch on both sides, just gives me a little scratch in there. I'm going to go 1.5 inches. I'm going to add 1 inch to that so that 1 inch past the face of the socket, I will have another line. Why? Because I'm going to weld it. When I weld it, what's going to happen to my line at the 1/2 inch mark? It disappears. You are correct. A brilliant one you are. So, with that being said, if that line's going to disappear, once I have it welded in place, if the inspector cannot come and look and say, okay, there's a scribe line at the 1 inch mark, then he or she will not know that I have to and I'll have to disassemble this to make sure I got my back out. Now, it is wrong and unethical to put your scribe lines on after you've welded it up. That's against the rules, and no pipe fitter worth a salt would ever do such a thing. Okay, so I got my 1 inch mark. I'm going to make that little scribe again. It's just a little scratch is all it is. But that scratch tells that inspector everything that they need to know. You don't want anything more than that scratch, because if the thumbnail could catch it, then you've actually taken away from you've gouged your pipe. You've taken away from material wall thickness. So it just has to be a slight scratch, visible. That's it, just for the inspector. Now what I can do is I can take my flanges and I'll take my gasket side out. So neck to neck, I'm going to push them in. You'll notice I've cleaned my pipe roughly about 2 inches. That way I have a good inch outside of my weld zone where it's clean. Now I'll take my pipe, I'll put it in place. And what I'll do is I'll take one of these flanges and I'll bolt it up. Just to hold it in place. I'll take the other one and put a bolt through there just to hold it in place. That's all I'm doing at this venture. Now I want to make sure that I align them up. Okay. The beauty of the P15 joint is I could actually see through the back side of my assembly as well, which is also a great benefit. So I'll snug these up. I'll have to move this one because I have a bracket over there on that side. That's why I said placement of your brackets is critical because they can get in the way. Now what I want to do is take my flange and bring my flange up to where it's level, where my flange is completely level with the other one, because you will have some kind of slop in your bolt holes. And the whole time you're doing this, you're going to be talking about what a bad pipe fitter the last guy was that built this original assembly. So I challenge you not to be that guy. You know that somebody put in shoddy craftsmanship, so put in a professional fit up right out the gate, and when the next person comes to replace your work, they'll say, hey, that pipe is decomposed, but the fitter did a good job. Okay, what I'm looking at now is I could take my stick and I could take my depth gauge and set it at 1 inch plus a half, because I have a 1 inch flange here, right? And this is part of the assembly on the vessel. This is the one that I need a 1/2 inch depth inside of. So I go to 1 inch and a half, and that's where the fitting of my pipe should sit. So it's got to go this way just a little bit. So I got my 1/2 inch inside there, and I got my, that's a little heavy, so I'll come here. And what I'll do is I'll come up here and I'll measure, and I look at my scribe lines. In some of these areas I have my 1/2 inch, and some it's a 1/4 inch. Why is that? Because my flanges are sitting like this. But it gave me enough where I could still put a weld on the inside of this piping system, and it'll work. So if that happens, split the difference. Just make sure you have enough room to get a weld in there. And when you're happy with it, let your inspector know. He's going to come and look at your fit up. He'll say, okay, it's good to go. Now what we're going to do is we're going to tack it. We're going to tack it off. Everything is clean, ready to weld. Our flanges are nice and squared off with the existing flanges, because we know that's what's on the vessel because the old one came out, right? And we are replicating that. All right. Now I'll go ahead and I'll tack it in 4 places. Eyes. There's 1. Eyes. Two. 3. 'Now that I have 4 tacks all the way around on both sides, I no longer need my jig, because I could unbolt this completely And the face of these flanges are going to be exactly as the face of those flanges. Now the benefits are, as previously stated, I don't need a hot work kit. I don't have to run leads. I don't have to get a fire watch. I'm in my shop working by myself on a Sunday, getting that overtime money. Now I'll pull it out. Of course, my flanges are cocked, so it's kind of hard coming out. But I could take this, and I could take this, and you can see they're exactly the same. See how one's cockeyed? The other one's cockeyed, just like it. No difference. No difference at all. This is going to bolt up just like that did because they both came out of the same jig, which is a replicate of what is on the vessel. So now what we're going to do, since it's a P15 joint, we're going to weld off the outside and the inside. As previously stated, cleanliness is next to godliness when you're doing this. So I'm going to clean off my slag. Another advantage is since it's on the bench, I can roll it. I can move wherever I want. When you were in weld school, you couldn't roll it because it was unauthorized. It was a fixed position. If this were on a vessel, I'd have to get up underneath it and weld it. All kinds of crazy positions. Right here, it's on my bench. So as long as it's welded professionally, I can weld it any way I want. Now what I'm welding with is the 7018 and 70,000 pounds of tensile strength per square inch. And I'm going to weld this off, then I'm going to weld the inside. That way I know I won't have any leaks. Here we go. Eyes. Now with the 1/8 inch electrode, your disposition rates are much higher. I prefer it. Of course, the 3/32 gives you a prettier finish, I feel. But this works out great. I'd rather put down metal. All right, so I rolled it. Now I'm going to go again. Eyes. Now, depending on what the data sheet says, how many passes do I need? Rule of thumb is going to be at least 2 passes. That's general engineering practices. But you have to look and see what the spec says. What does the spec require? It'll usually say, 2T, 3T, whatever. What that means is it's 2T would be 2 times the thickness of the material. So If you had a 1/4 inch, you need a 1/2 inch worth of weld, right? Now I'm going to proceed with welding on the Leaning Tower of Pisa. And then, when I go to do the other side, since I am on the bench, and I don't have to go onto the ship and get it all out of position, I could turn it upside down, and I could take my clamp, and I could adjust it, and I could just weld it right there. So what I'll do is I'll just do one pass. That's all you're going to do on the inside is one pass. That's just the seal weld. And here we go. I'm focusing most of my heat onto my flange. Why? Because the flange is thicker than the wall thickness of the pipe. If you're not comfortable running this pass, you can stop, reposition, and resume. It takes a little time to get used to that. And make sure you don't weld over the gasket seating surface. That's why we got that pullback. And voila. Now, I could take my chipping hammer, clean that off, clean the inside of that pipe so I don't have any slag inside of it. And what I have is, that was one continuous pass, quick and easy. And I'll clean it out. It's hard to get a wire brush in there because your wire brush is bigger than the pipe, but you can see inside it's welded off completely and it didn't affect the seating surface where the gasket's going to go. So it can still go inside there. It's welded all the way around. I would repeat the same on this side, and then when I got done, I would simply take it down to the vessel. I would stick it into place and I would rotate it until it fit, because we already know that my flanges are not square. Okay, so that's going to be like that, it looks like. We already know the flanges are not square, so you have to be able to identify where they came from. Right there and right there. Now I can bolt up, put in my gasket, tighten up my bolts. And you'll feel it kind of drop. There it is. You'll feel it kind of drop when you're in just the right place. There it is. You'll feel it drop right into place. That way you know you got a good assembly, and you can take that to the vessel and just bolt it up. And that's how you make a spool piece. And this, folks, is how you replicate an unsquare spool piece. Make it wrong to make it right. We appreciate your time, and we'll see you next time.
Thank you for watching our video today. I hope you enjoyed it. I hope you learned something today. If you would like to get some more tips and tricks and become a better welder, then subscribe to our channel. And if you would like to learn even more right now, then click on our link. Thank you, and we'll see you next time.